Example, Live Nation, the company that organizes AC/DC concerts on their Black Ice Tour, which for any of the AC/DC trivia nuts in the audience, that's from 2008 to 2010, wants to figure out how much merchandise they should bring to their concert in Vancouver. A program occupies 5 cubic inches and a hoodie occupies 50 cubic inches. A program costs Live Nation $5 to make. A hoodie costs $20 to make. The company wants to spend no more than $51,000 on their merchandise per show. There's a maximum space of 75,000 cubic inches for merchandise per concert. The company expects a profit of $20 per program and $105 per hoodie. How many hoodies and programs should they sell to maximize profit? Well, the first thing we should do is identify our variables here. What are our variables? So, hoodies and programs. Cool. So, it's a little thick. Let's let H represent the number of hoodies. And then let's let P represent the number of programs. Okay?
What does it mean by program?
So, those are our let statements. So, for all intents and purposes, this is our step 1. Come up with the let statements as far as defining the variables, right? That's our step 1. So now, what do we do after this? What do we do after this? So let's make this really easy with the inequalities. Let's make this really easy. And let's say that we have H is greater than 0, P is greater than or equal to 0 too. Those are 2 of the inequalities for sure. Because you can't have a negative number of hoodies, just like you can't have a negative, okay? So hoodies have to be greater than 0, programs have to be greater than 0. Then, from there, what we should look at is considering the quantities in this question. What quantities are going to make up our other inequalities? So, volume and cost. Cool. So let's look at the volume first. We are told that the program occupies 5 cubic inches and a hoodie occupies 50 cubic inches. So those will be useful, as well as the 75,000 cubic inches. Those will be useful for that first inequality, because we have that hoodies occupy 50 cubic inches, so that's 50 times the number of hoodies, plus 5 times the number of programs, has to be less than or equal to the 75,000, which is the total storage available to Live Nation for every concert. So that would be the inequality that has to do with volume. Can anyone tell me what the inequality would be for cost?
It would be 5p.
5p?
I guess, would you want to put h first?
I could put 5p over here. 5p over here.
Plus 20h.
Yep.
Is less than or equal to 51,000.
Yep. There you go. So there's our 2 inequalities. There's our 2 inequalities for this question. Okay. Now, yesterday we talked about objective function. The objective function is something that we use to do the extra stuff that we're going to be doing later this morning or this afternoon or whenever we are. And the objective function, we are basically trying to maximize profit. Now, like the ladies this morning reminded me, we already have a P, so it probably isn't a good idea to use P as our variable. But why don't we use M for money? So M is going to equal, it's $20 per program profit and 105 per hoodie. So 105 times the number of hoodies plus 20 times the number of programs. Now, what do we do? Well, we should use something like Desmos to see what our scales should be. Now, this is different than how I did it this morning, which is totally fine. This morning, I think P was my X, but that's fine. It's not a big deal. It really doesn't matter. So H is our X and P is our Y. And we want to find out what our scale should be. Maybe we'll make it vertically that every grid square is 1,000. So that means every 5 grid squares is 5,000. So 1, 2, 3, 4, 5,000. 1, 2, 3, 4, 10,000. 1, 2, 3, 4, 15,000. 1, 2, 3, 4, 20,000. And this is 25,000. Okay, so that's for the number of programs. So just as a reminder, every grid square counts as 1,000. So I just labeled every 5 grid squares. If you go horizontally, we go up to 2550, which is a real shame. A real shame. Because if every grid square was 100 on the nose, we could get to 2,500 at the end. It's literally 50 over that. So we should probably try and think of a different scale. It doesn't matter what your scale is here. It might make more sense to have every grid square go up by 100, but that would only get us to 2,500. What if every grid square was 200? If every grid square is 200, then every 5 grid squares is 1,000. So that's 1,000. That's 2,000. That's 3,000. That's 4,000. And that's 5,000 on the end. Okay? So now we've got our scale drawn. Once we've got those intercepts drawn, then we can go ahead and connect those dots with a nice straight line with our ruler. And then we can go ahead and create the line with the other points. 10,200 would live somewhere like right here, and 2,550 would live about right here. And then it's just a matter of connecting these dots with a nice straight line. And seemingly, we have an intersection point right here. So that intersection point, so mine's a little bit off some way. I don't know what I did wrong. Maybe. So your intersection point is 807,000. And from Desmos, we shade in the area that is here. This is the shaded in area. We should label these inequalities on the graph itself. So the red line that we drew is going to be the 50H plus 5P is less than or equal to 75,000. And this blue line is going to be 20H plus 5P is less than or equal to 51,000. And when we do that, our graph is complete. This is complete.
What if
this is where the fun begins because this is the new stuff. So I'm going to take a wee picture of the solution area. And this picture is what we're going to use down here for the objective function. We'll do this in just a second, but basically the objective function uses this point, this point, this point, and this point. Those are the 4 key points, the vertices, if you will, for the shaded area. So what are the coordinates of those points? Well, the coordinates of those points are 0, 0, 0, 10,000, 800, and 7,000, and 10,000. Oops, sorry, not 10,000. It's 1,500. My bad. 1,500 and 0. 1,500 and 0. Remember that in our ordered pair, hoodies come first, programs come second. So these are 4 possible combinations of hoodies and programs. And what we're going to do is we're going to evaluate the objective function for all 4 of those order pairs, and we're going to see which one returns the maximum, the highest profit. So right off the bat, you should be able to tell me which one is not going to be the winner. 0, 0. It's gone. See you later. It's not going to work. Okay? It's going to be one of the other 3. Let's plug it in, all those points, to see which one works. Okay? So, for the first one, it's 105 times the number of hoodies, which is 0, plus 20 times the number of programs, which is 10,000. So when we multiply anything by 0, we get 0. When we multiply 20 by 10,000, we get 200,000. So 200,000 is the profit to beat. When we plug it in to the other 2 order pairs, we got to beat 200,000. So let's try the second one, 800 and 7,000. So it's 105 times 800 plus 20 times 7,000. 105 times 800 is 84,000. 20 times 7,000 is 140,000. So if we add those together, we get 224,000. So right now, that has overtaken the other point as the combination of hoodies and programs that maximizes the objective function. Now, we have not tried the last one. We have to try the last one before we completely declare this one the winner. But it's looking like it is going to be the winner. Okay, last one, 1,500 hoodies. So that would just be 105 times 1,500 hoodies. And in this particular combination, there's no programs being taken. So if we find out what 105 times 1,500 is, we get 157,500, which is a lot of money, but it's not as much as if you did the 800 hoodies and 7,000 programs. So we're going to summarize this with a therefore statement and say that Live Nation should take 800 hoodies and 7,000 programs to Vancouver. with second example. Here we go. A doctor advises a patient to take vitamin supplements to provide at least 35 milligrams of vitamin C, but no more than 600 milligrams of calcium daily. Each brand A pill contains 100 milligrams of calcium and 5 milligrams of vitamin C. Each brand B pill contains 150 milligrams of calcium and 10 milligrams of vitamin C. Each brand A pill costs 4 cents and each brand B pill costs 9 cents. How many of each type of pill should the patient take daily to minimize the cost of taking vitamins? Okay, so first step, what do we, actually, you know what? Just 1 second. All right, so first step, let statements. We define our variables. So define the variables for me, somebody, on that. So maybe it should be something like let A represent the number of brand A pills. And let B represent the number of brand B pills. Okay? Now, what's our next step? Inequalities. So let's do it.
Volume and cost, right?
A is greater than 0, B is greater than 0. And then we're also going to look at what quantities are we looking at here.
At least 35 milligrams of vitamin C.
So vitamin C
Vitamin C
and calcium.
calcium.
Those will be what our two inequalities center around. The amount of vitamin C and the amount of calcium. So, for the vitamin C, let's look at the question. You want at least 35 milligrams of vitamin C. Each brand A pill contains 5 milligrams of vitamin C. Each brand B pill contains 10 milligrams of vitamin C. So for vitamin C, it's going to be 5A plus 10B is greater than or equal to 35. That's for the vitamin C. Okay? For calcium, it's a maximum. So it's going to be less than or equal to 600 for calcium. And brand A has 100 milligrams of calcium. And brand B has 150 milligrams of calcium. So it's going to be 100A plus 150B is less than or equal to 600. Those are the inequalities for this question. Now, the objective function, or what we're trying to minimize or maximize, is the cost. And we're trying to minimize the cost of the vitamins. So none of our variables are C. So I am going to use a C for the cost. The cost is 4 cents for brand A. So I'm going to write this as 0.04 times the number of brand A pills plus brand B is 9 cents. So it's going to be 9 cents times the number of brand B pills. Now, any questions so far? Okay, so then we graph this. And I can tell, so again, if you use the intercept method, I could cover this up and see that this is going to be like 3.5. Cover this up, see this is going to be 7. Cover this up, it's going to be 4. Cover this up, it's going to be 6. That's good news because it tells us that 0 to 10 will be enough for a scale for both of these. 0 to 10 will be a good enough scale for both brand A and brand B pills. So there's 25 grid squares though. So how are we going to use a scale like that? We could do it this way. This is different than I did this morning. But let every 2 grid squares represent 1. 1, 2, 3, 4, 5, 6, 7, 8. 9, oopsies, that's 1 over where it should be. 9, 10, 11, 12. So that's the number of brand A pills. And we'll do the same thing going vertically. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so in order to know where the intercepts and all are, the best thing to do is to type this into Desmos. Okay? What does a very small area mean? It means that there are not very many possibilities. There's not very many possibilities that are going to satisfy the inequalities, right? The 2 inequalities we have, the amount of vitamin C and the amount of calcium, the only possible outcomes are in this little shaded area here. Are there possibilities? You bet, but they're very limited. They're very limited, okay? We should, and I hope you have already done this, this is more of a me thing. We should label the lines. So I'm going to do what Caleb mentioned. I'm going to number these because I'm going to just put a 1 there and a 2 there. There you go. Done. Okay?
Isn't it the other way?
Nope.
No?
Nope.
I thought the blue line is...
Well, it depends. Yeah, no, my red line is the vitamin C, and my blue line is calcium. Yeah. No. So, okay, what are our key points? Because in this scenario, if we're only going to use the corner points, to use to evaluate the objective function, the intersection point's easy. The intersection point is 3, 2. Okay? There's also, this is a triangle, so a triangle obviously only has 3 ordered pairs. 3, 2 is 1. We have 0 and 3.5, which I want to talk about, and we have 0 and 4, which I want to talk about too. So let me ask you this. I asked the group this morning because this reminds me solely of the question we did not too long ago on the chickens and the turkeys. And it was funny because when I taught that lesson individually to Brianne, she emphatically agreed with me. Yeah, you can't have half a chicken, you can't have half a turkey. So that's what Brianne and I decided on. And then I taught the lesson to you guys, and you're like, of course you can have half a chicken. You can definitely have half a turkey, no big deal. So then we went with that kind of idea. Cool. Let me ask you this: Can you take half a pill?
Mm-hmm.
You can, yeah.
You can. You can take half a pill. I think we could start getting a little silly if we have to take like a third of a pill, or like 0.16 of a pill. That would start to get really kind of out there. But lots of pills actually come with like little things that you can kind of snap them or cut them very easily. So okay, so we can have half a pill. Cool. Because if we couldn't have half a pill, then we'd have to do something about this. But we're assuming we could take half a pill. I'm good with that. Now, let me ask you then. If we're trying to minimize cost, if we're accepting half a pill as a possibility, which of these 3 combinations goes out right away?
Mr. 1, 3 is
So, which one of these possibilities takes a hike? What do you think?
3 and K.
What's that?
3 and K.
No,
4.
0 and 4. You know why? Because think about this. If we're trying to minimize cost, what's going to be cheaper? None of these and 3.5 of these, or none of these and 4 of these? Which one's cheaper automatically? 3.5 is always cheaper than 4, right? If 3.5 is always cheaper than 4, then we don't even have to worry about that possibility. Because if you have 4 of something, it's going to cost more than 3.5 of something, right? Okay, so we're really only testing these 2 possibilities. So let's get to it then. So the cost is 0.04 times 0 plus 0.09 times 3.5. So 0.09 times 3.5 is 31.5 cents. Okay, cool. That's the cost if we have 0 brand A pills and 3.5 brand B pills. That's the cost. Now let's look at what the cost is if we have 3 brand A pills and 2 brand B pills. So cost is going to equal 0.04 times 3 plus 0.09 times 2. And that's going to be 0.12 plus 0.18, which is 30 cents. If we're trying to minimize the cost, does the first point do it or the second point do it? What's smaller? This or this? 3.2. That's right. This is smaller. So we'll put in our therefore statement. The patient should take 3 brand A pills and 2 brand B pills, period. One last example right here. This one is just a picture, a graph, if you will. The graph is already done for us, and it asks to find the optimal value. Now, let me ask you this. It doesn't specifically say it, and it should say it, so that's my bad. But we can tell where our corner points will be for this. Our corner points are going to be right here, and right here. Do you think we're going to be minimizing or maximizing?
Maximizing.
No. Here's why we're minimizing. If we were maximizing, this graph keeps on going forever and ever to the right, and this graph keeps going on forever and ever and up. There's no way to maximize this because there's no maximum, but there is a way to minimize. So like I said, the question should have asked us to do a minimize. That's not how you spell minimize. But we're going to minimize the objective function. So the coordinates of these points are 0 and 19, 10 and 4, and 15 and 0. And this is unlike most of what we've been doing for the last few days. There's no context to this question. We're not selling programs and hoodies. We're not trying to get our calcium and our vitamin C levels to where they need to be. This has nothing to do with that. There's no context here. So this is actually just basically looking at what that last step is isolated by itself. So we're going to take the objective function, which is right here, and we are going to evaluate it with those 3 points to see which one will record us with the lowest final value. Okay, so n equals 4 times x, which is 0, plus 3 times y, which is 19. So that's just going to be 57, because 3 times 19 is 57. The second one is going to be 4 times 10, plus 3 times 4. So that's 40 plus 12 is 52. So 52, of course, is lower than 57. So we'll do the last one to see if it will be even lower yet. 4 times 15 plus 3 times 0. 4 times 15 is 60. Of course, that's not lower. So in this particular case, 10.4 has the lowest value. So that is going to be the point that minimizes the objective function. So therefore, 10.4 is the point that minimizes the objective function.